Hi, in this video I will be discussing one of the RC circuit examples. Its calculations, so we will be using the concept, the basic concept as a definition, also the formula we used in our previous videos. Now, um, in this example, I'm asking you, in this RC circuit, the capacitor is initially uncharged when the switch is closed. That's a key thing. So it is uncharged, so we are going to a charging process. Now, how much charge is stored on the capacitor at t equal 0.85 second, and how much current is running through the circuit at the same time, which is 0.85 second. Now, this setup of the circuit, soon as we close the switch, it is telling me we are using a charging process because I have a battery with a capacitor and a resistor. So the battery will supply the capacitor with the charges required to make it having a potential difference between the two plates. So to calculate how much charge is stored on the capacitor at that time, we should be using this formula. Q as a function of time will be Q max multiplied by 1 minus exponential t over RC, which is a time constant. Okay, but if we look carefully, we don't have the time constant or the value of RC, and we don't have the Q max. It's easy if we start calculating that. So the time constant, which is R times C, that will be 220 multiplied by 4.210 to the power minus 3. And if you do the calculation for this one, it will give you 0.946 seconds. So that's the first time constant for this RC circuit. As a definition, this is the time required to fill this capacitor with a 63.3% of the maximum charge can be stored in this capacitor. Okay, now let's find the Q max. How much is the maximum charge can be stored? Well, it is the capacitance times the maximum voltage we can have, which is the battery voltage. So I can write this from here. It is 4.210 to the power minus 3, and the voltage is 18. Doing the calculation, that will give us 75.6 10 to the power minus 3 coulomb, or 75.6 millicoulomb. Right, great. So I have the values of the Q max, I have the value of the RC, or the time constant, and I know which time I'm trying to find how much charge being delivered or stored in that capacitor. The time is 0.85. So let's do the calculation now. Once again, the equation is when t equal 0.85 second, it says Q max 1 minus exponential t over RC. Now, if we're replacing the values, I have the Q max, it's 75.6 10 to the power minus 3, and here is 1 minus exponential minus 0.85 over 0.946. All what you need to do is to plug these values into your calculator and do the math. Let's find first the exponential value. That will give us here 75.6 10 to the power minus 3, and here's 1 minus 0.4, and that's mean now it's easy to calculate this. Here we go. The answer will be 45.36 millicoulombs. That's how much charge will be stored in this capacitor at that specific time. All right, so that was the first question in really detailed how you should tackle it and which values you should be finding. Now the second part is how much current running through the circuit at this time. We know that as a start, when immediately when t equals 0, the maximum current will flow through the circuit. So to find that, we can say, all right, the formula is I equal t 0.85. We could speed things up and say, okay, it is the maximum current exponential minus t over RC. Now, how we calculate the maximum current? It's the voltage across the battery divided on the resistor minus t over RC. Now, you just need to do the replacement, just plug the values. Here it is 18 over 220, and when you do the exponential, it will give you 0.4, and all this will give you 32.7 milliampere. All right, so that's how much current at that moment. So the current will be decaying as we go, or as we charging the capacitor, and it start to vanish, not crossing the resistor as the time goes. So if I compare this value with the maximum value, when I say 18 divided by 220, you will find that there is a difference. That means the current is going down or is decaying or vanishing. Okay, I hope you found this example is useful about charging a capacitor in an RC circuit, and I will see you again with other videos. Thank you.